In the previous video, I talked about graphing equations that were written in the slope-intercept form. Of course, not all linear equations are written that way, and another common way to write them is in what is known as standard form. An example of a standard form equation is x plus y equals 5. In a standard form equation, the x and the y variables are on the same side of the equation, and there is a constant on the other side. Just like equations that are written in slope-intercept form, standard form equations can be graphed several different ways, and I will talk about those ways in this video. Just like slope-intercept form equations, one way to graph a standard form equation is to set up a chart and plot the points. So if we have the equation x plus y is equal to 5, one thing I could certainly do is I could set up a t-chart and start putting in points for x, or numbers for x, and solving it for y. So if x is 0, y is 5. If x is 1, y is 4. X is 2, y is 3. And I'm going to just finish off doing a few more of these. And you can see that I could certainly go through and get a number of different points that would satisfy that particular equation. So now I've gone ahead and I have graphed all of those points, and you can see right here is the point 0, 5, here is the point 1, 4, 2, 3, etc. And once again, I do want to make sure that you do have this where I just drew the arrow noted. Remember, I put arrows on either side of it, and putting arrows on either side of it indicates that it goes on forever and ever. And also, every coordinate pair on this line, shown or not shown, is the solution for the equation. Making up a t-chart and putting in points certainly does work for graphing standard form equations, but truthfully, there is another way as well. So here's another example of a linear equation. 6x plus 2y is equal to 6. However, it's not quite as easy to graph this just by picking a value for x and determining what y is based on that, as the one we did previously. So, once again, after setting up your chart, I suggest that you graph this standard form equation by following 5 different steps. Rather than me reading through all 5 of these steps, I'm going to let you pause this, read through the 5 steps yourself, and then start this up again, and I will go through the 5 steps with that equation. The very first thing to do after setting up your t-chart is to let x equal 0, so then you can just solve for y. If I let x equal 0, it's going to go through and it's going to eliminate that 6x, so I'm just going to have 2y is equal to 6. So it's very easy now to know that if x is 0, y is equal to 3. The second thing to do is to then let y equal 0. When I let y equal 0, it's going to eliminate that 2y, so I'm just going to have 6x is equal to 6, so I know now that x is equal to 1. So now I do have 2 different points that I can plot, and I'm going to go through and I am going to plot those 2 different points. Now I am plotting, here's the point 0, 3, and here's the point 1, 0. So I already have 2 spots that are plotted on there. After that, I would go through and look at what the slope is between those 2 points, and I would use the idea of slope to find the third point. I know that to get from one point to the next point, in other words, to get from this point up to the other point, I have to go up 3 and over 1. So I could find another point by going up another 3 and over 1, and this would have to be another point on that line. Now, another point on that line then, this would be the point -1, 6. And I could put that in my t-chart if I wanted to as well. If I wanted to, obviously, I could find another point. This time I'm going to go down 3 and over 1 using the idea of slope and put in another point. and that is at the point 2, negative 3. So once I've done that now, I really have 4 different points. I really only need 3 different points. And I do want to make sure that whichever extra point I'm going to be using does work in my equation. So I have the equation 6x plus 2y is equal to 6. I want to make sure that the point negative 1, 6 does satisfy that. If I put negative 1 in for x, I get negative 6. If I put 6 in for y, I get 12. And certainly negative 6 plus 12 does equal 6. So now I can go through and I can graph my line, and my line would look similar to that. Following these 5 steps is a pretty easy way of doing this, because once again I am giving the y-intercept and the x-intercept right away, and then using the idea of slope to find some other points. Here's another example of a standard form equation to graph. Please pause the video and graph it yourself on a piece of graph paper, and then watch me graph it using the 5 steps. Step number 1 says to let x equal 0 and solve it for y. So if x is equal to 0, it eliminates that 3x, so now I have negative 5y is equal to 15, and in that particular case, y would be equal to 3. The second step says to let y equal 0. If I let y equal 0, it eliminates that 5y, so I have 3x is equal to 15, so now x is equal to 5. So now I can go through and plot those 2 points. Here's the point 0, negative 3, which is also known as the y-intercept. Here's the point 5, 0, which is also known as the x-intercept. Those are 2 points that would satisfy that particular equation. To find a third point, I'm going to take a look at what the slope would be between those 2 points. To get from one point to the next point, I could go down 3 and over 5. So to get to another point, I'm going to have to go down 3 and over 5, which would put me at this spot right here. That particular point is the point negative 5, negative 6. So the next thing that I want to do is I want to go through and I want to check that and make sure that that is working in this particular equation. So here's the equation, 3x minus 5y is equal to 15, and I'm going to put that negative 5 in for the x, I'm going to put that negative 6 in for the y. So when I do that, and I'm just going to show this, 3 times negative 5, subtract 5 times negative 6, does need to equal 15. 3 times negative 5 is negative 15. Subtract a negative 30 does equal 15. And negative 15 subtract negative 30 does equal 15. So this particular point works. Then, because I know that particular point works, I can go through and I can graph my line, and that would be how to go through and do that particular problem. At the beginning of this video, I mentioned to you that a standard form equation is one in which the x and y variables are on one side and the constant is on the other side. It is certainly possible, however, to have equations with only one variable, and I have 2 examples below. The first one is x equals 3, and the second one is y equals negative 4. Both of these equations also create straight lines, and you need to be able to graph them as well. To understand what these equations mean, I am going to set up charts for both of them. So here's a chart for that very first equation, x is equal to 3. It tells me that x always has to equal 3, but it doesn't tell me anything about y. So I could make y 0, or if I wanted to, I could make y 1, or if I wanted to, I could make y 2, because it doesn't tell me anything at all about y in this particular equation. If I wanted to go through and graph this now, I would just go through and graph these particular points. So here is the point 3, 0. here's the point 3, 1, here's the point 3, 2, and you see I could continue to go on in both directions. So this particular graph is just a vertical line that is parallel to the y-axis at x is equal to 3. For the other equation, y is equal to negative 4, I'm once again going to go through and I'm going to set up a t-chart. And in this particular t-chart, it tells me that y has to equal negative 4. It doesn't tell me anything about x, so I can make x anything I want to. I can make x equal to 0, or if I want to, I can make x equal to 1, or if I want to, I can make x equal to 2, and so forth. Once again then, I can go through and I can plot these points. Here's the point 0, negative 4. Here's the point 1, negative 4. Here's the point 2, negative 4. And once again, you can see I can go in and I can put in as many points as I want to and connect those. The graph of y equals negative 4 is a horizontal line going through y equals negative 4 that is parallel to the x-axis. You do need to be able to solve or to graph both of these types of equations as well as we go through this particular module. Please look for additional practice problems in this module if you are interested in having more practice on graphing standard form equations. Once we start doing practical problems, graphing both standard form equations and slope-intercept form equations needs to be second nature to you. If I can give you any additional assistance, please be sure to ask.